That's great. Okay, cool. So maybe I can introduce myself. So my name is Torsten Straus. I'm a consultant, trainer, and regular speaker at national and international conferences. I guess I have delivered more than 150 presentations over the last years, or maybe 99% about database, SQL Server database tuning, performance tuning, and SQL Server internals. So especially everything which is related to the engine, because I personally feel that when you have a good understanding about the engine, you have a much better understanding about how to solve issues and even foresee problems and do performance tuning, everything like this. Yeah, maybe worth to mention, I'm also a Microsoft Most Valuable Professional since a few years, and that's me. I think the most important one is maybe my email address. So when you have any kind of question regarding this presentation, regarding performance tuning on a SQL Server in a large or even small environment, feel free to reach out to me. That's it. Yeah, let's go to this slide. So you can, George, you still can see the screen, even if because I switched the application, you can see management schedule and all, right? Okay, perfect. Because sometimes people complain after 10 minutes that they only can see PowerPoint presentation. So that is the reason why I'm asking. Okay, cool. Let's talk a little bit about the query restore, because in order to detect plan regression, I think the only way is to use the query restore, which was introduced in SQL Server version 2016, if I remember correctly. So I think most of us will run the SQL Server environment on SQL Server 2016, 17, or even 19. Yeah, definitely makes sense. If you are not on SQL Server 2016 yet, it is definitely worth to upgrade, not just because of query restore, also because of other great features and performance improvements. This is definitely something you need to consider. But as we will see later on, migrating a database from an older version to a newer version like SQL Server 2019, we will see this have its own challenge. So, and the only way to detect the challenges is to use another time query restore. As we will see, we are talking about plan regression because of the cardinality estimator. So we will see the cardinality estimator, the algorithm and the way it is working later on. Yeah, sorry.
Can I just 1 second? I know somebody popped in and said they can't hear up, or somebody else. Is everybody else able to hear the presentation? Can somebody else chime in? Unmute yourself, or okay, nope, he's got it. Sounds like
Okay, cool.
He's got it fixed.
Great.
Okay, good.
So I can go ahead, right?
Yeah.
Okay, great. Yeah, again, so we will see the cardinality estimator, and honestly, with the upgrade to a new SQL Server version, again, so the cardinality estimator is definitely something you have to worry about. I have a lot of customers complaining about, I would say complaining about slow performance after upgrading to SQL Server 2016, 17, or even 19. Most of the queries are running much faster, but some of the queries are definitely so much slower. And most of the time, this is really the reason, the root cause for the entire performance decrease is the cardinality estimator. And this is definitely something you cannot detect and you cannot even handle with the traditional DMVs. You know, that we have a lot of DMVs available, which are still there. I do not want to call them legacy. I think they will be there forever, but the query restore is just another way to visualize I would say the impact of your workload. Yeah. So this is something I think this is the benefit of using query restore. So you can see the query store is there to collect query and plan information and runtime statistics. And as we will see, the query store have two stores. One is about the query and plan information, and the other one is the runtime statistics. And these are definitely two different memory clerks. When I talk about memory clerks, that means everything is, first of all, saved in memory, and later dependent on the so-called data flush interval, as we will see. These kind of information, these kind of details are hardened in the primary file group. This is definitely something which I do not like, because we do not have a chance to tell the database or the SQL Server, do not save the information to the primary file group, save it to another file group. That is not possible. That is something you need to consider. Whenever you set up your query store, you have to ensure that your primary file has the right size, because otherwise we will see, maybe I can present this, but you can believe me, that the primary file is increasing over time. And this is something maybe you didn't calculate it, and that can cause a problem. Because I hope that every one of you have at least another file group where you save all the data, and maybe even another file group where you save all the indexes. Even if you run just on one partition, that is definitely something you need to consider, or you should consider because of the system pages. Yeah, so there's definitely something which can be handled when you even have more than just one file group on even one SSD drive. Yeah, that is already a big difference here. But again, this is not possible. Query store will always send the data to primary file group. Okay, so what can we do? We can use the query store to identify the top N queries. That's perfectly fine. This is something which we can do with the traditional approach as well. But we will see we have a few reports available when we enable query store. And this is definitely a great way to visualize workload. Instead of using DMVs, you can use reports. And people are more, how can I put it, attracted by reports. So that is definitely the better way to do it. So you can also analyze the resources, the usage patterns for a particular database, and you can detect plan regression caused by SQL Server upgrades. This is what I already mentioned. So you can also have plan regressions caused by server and database settings, by hardware changes, or even plan changes. And what you can do, and what I definitely do not recommend, and what I definitely do not like, that it is so easy, is to force a specific query plan for a specific query. That is definitely something I do not like, and I wonder why Microsoft decided to make it so easy for us to force a specific plan for a specific query, because we will see that this can have a tremendous performance impact. Yeah. So what is also possible is enabling automatic plan correction. This is a feature which was introduced, I think, in 2017 already. Yeah, in 2017. This is based on query store. And we have something which is automatic index management, which is a feature which is only available in Azure so far, not in the current version of 2019 on-premise. So that is not there, but I'm pretty sure it will, that Microsoft, everything is developed in cloud first. Yeah. So, but I'm pretty sure with the next on-premise version, we will see the feature also. You can use it on a local machine as well. So there's a big difference about the query store and the traditional approach. And when I talk about the traditional approach, this is about DMVs. Yeah? So you know all the DMVs for performance tuning, hopefully. But again, there's a big difference. The main difference here is that the runtime statistics and the execution plans are written to disk and will outlast a SQL Server restart. I've seen a lot of customers. They call me and tell me my SQL Server was running slow, and we restarted SQL Server. Now it seems that SQL Server is running fast again. Please do an investigation and explain why the SQL Server was running slow. There is no way to figure out why the SQL Server was running slow after you restart your SQL Server when you do not have query restore in place. Because again, query restore, all the information which are gathered over time will be sent and saved in the primary file group, right? This is definitely something which you will lose when you use your traditional DMVs. All of them, all of the information are just kept in memory. That's it. Okay. So the good thing is that for the query store, all information are already captured on the statement level. So you know that a lot of DMVs which are available only captures information on the batch level, which means that you always have to use the I think the offset, and you do some kind of string manipulation in order to get the information on a statement level. Think about a stored procedure with different statements. So it will only tell you the performance of the stored procedure, but not of the statement. So and this is different with query restore. Yeah, another difference is that whenever you enable query restore, by default, all native compiled stored procedure, that means in-memory OLTP, all the information about runtime statistics and plan statistics, it depends a little bit because, you know, when you have a native compiled stored procedure, you do not even have a plan because this is just C code. Yeah, but if you use the so-called query interopt engine, which means you can use what is it? A compiled stored procedure, not a natively compiled stored procedure, but a normal stored procedure to access in-memory OLTP data. So in this scenario, we still use the query optimizer and we will get back a plan. So all this kind of information are also captured by default. This is something where you have to ensure there's a specific stored procedure which you have to enable, which is called this SP-XTP control query exec stats. When you enable this, you will get the information with the traditional DMVs as well. But honestly, people always forget to enable to enable the switch. Yeah. So query restore, as mentioned already, makes it very, very easy to detect plan regression, to understand your workload, even with, I think we have 5 or 6, I think we have 6 reports which are available, which you can definitely use, and I like the reports. The problem with the reports is that you will have a lot of more information when you use the information which are collected over time by the query restore by using I would say the views which are still there additionally to the reports which we have. So when you really want to use the query restore and get the most out of it, the only way to do it is to use the DMVs which are based on the query restore, right? But the reports will already give you a very good idea about the workload and plan regression and all the other things. And there's another point here, which is definitely worth to mention. You can enable query restore on a database level. That is something which you cannot do with the traditional DMVs. DMVs are always captured on instance level. There is no way to disable a specific DMV for a specific database. And I mentioned that because the query restore has its own impact. I don't know. So sometimes people are telling me it's something about 3 up to 9% of CPU. Sometimes I can see that we have memory issues. So the memory clerk, so the memory consumption is growing over time. So whatever is true, we have some impact. We have also impact on the I/O, on the primary file group, because we will send all the information to the primary file group after a specific interval. That everything is true. And think about the following. You have a system which is running slow, and now you want to analyze a system which is running slow. You enable query restore on an instance level for all databases. That means you have an impact on the performance. That means you will harm the performance by enabling query restore to detect performance issues. You already understand the problem. That means you should be very, very, how can I put it? It is a very careful decision about when enabling query store on a specific database and on which database. So that is definitely something I wouldn't recommend to enable query store on every database by default. This is something you shouldn't do, right? Okay, so that's about the comparison between the traditional approach and the query stores. And by the way, I just wonder, do we have? Yeah, I can also switch to this one. 1 second. I have a lot of versions of query store. Yeah, let me follow here. So we got follow this this script here. It's almost the same, but it's already reduced a bit. I already told George, query store is something which is even hard to teach within an entire day. Yeah? So we only have 1.5 hours. Nevertheless, we can start. So there are information available, there are reports available. Whenever you enable query store, you can do it from a GUI perspective, or you can use stored procedures in order to configure the query store, which is definitely the better way to do it. But first of all, I will show you the GUI. And here you can see whenever you enable query store, which is by default off, you set it to read-write. You can configure a lot of settings, and we will go through some of the settings later on. But the important one is to mention that the query store folder, and maybe I can show it to you. So you can see query store folder, this one, is not available in my Contoso data warehouse because query store was not enabled on the database. That means when you're looking for the reports, when you're looking for the query store information, you have to ensure that the query store is running. Otherwise, you will not even see the reports. Okay, which I like because this will already give you an idea whether the query store is enabled or not. But people sometimes ask me, I cannot see the report. I cannot see the query store reports. The reason is query store is not enabled, right? And you can see we have even 7, right? Yeah, we have 7 reports, and we will go through some of them. So the most important one, for me at least, is the top resource consuming query. And query rate statistic is a nice one, and the overall resource consumption. So regression, also the regressed queries is something I don't like. Because the funny thing is regression means that you have a comparison between 2 plans. By default, the regression, also the regressed query report will already show execution, also query executions with just 1 plan. But if I only have 1 plan, how can I have a plan regression? That is not possible. So you have to adjust the settings when you open the report in order to see the plan regression, the queries which are really suffer from plan regression. And this is something which I can do with the top resource consumers as well. So why should I use another report which is already part of another report? So that is my personal opinion here. Okay, so at least we have 7 of the reports, and we will go through maybe 2 of them. I think the most important one. So let me open the architecture. I have to scroll down. Query store architecture. Here we go. So I already mentioned at the beginning, and now I have a problem with the WebEx. 1 second. Okay. I have a window in front of me. Okay, now it's gone. Okay, perfect. You can see this is the architecture. Let me blow it up a little bit. So as mentioned, the query store consists of 2 stores. First of all, we have the plan store, this one, and we have the runtime statistics. And the reason that we have 2 query stores, which are described as 1 query store, is the following. Whenever we execute a query, or we ask SQL Server to execute a query, first of all, SQL Server has to create a so-called execution plan. So that is the, I would say we have the parsing, we have the compilation, we have the optimization, we have a lot of phases in order to get a query plan. Yeah. And this is, by the way, only the best query plan SQL Server can found in a specific time. There is a specific threshold, just by the way. And whenever the query plan is available, usually you will see the query store, not the query store, the plan in the so-called procedure cache. That is something which is available upfront. That means the query can never ever be executed without having a plan. That is a reason why the plan information can be sent synchronously to the query store schema. All right. So once a query is executed, only then we have runtime statistics. We know how long the query was executed. I don't know how many memory, the memory grant. We can see CPU impact, we can see IOs, we can see a lot of things. And this information will send asynchronously. Second. I have someone will comment. No. Okay, no worries. I don't know what happens here. So okay, so once the query is executed, we only have the runtime statistics available at that point in time. So that means this information will be sent to the query store after the execution of the query. And normally it works like this, that SQL Server tries to reuse a saved plan from the cache. That means it is very unlikely that we will have another plan and another plan and another plan with every execution of the same SQL statement, especially when you use stored procedures, right? So that means the information or the frequency of having new plans available for the same query is not the same frequency as the runtime statistics, but we can execute a query over and over and over again, 100 times or even 1,000 times, or even forever with the same plan information. That means the runtime statistics, which are currently, I would say, kept in memory here, right? This has a much bigger impact. That means when SQL Server now send all the information synchronously to the primary file group, yeah, really it is an IO, it is a physical operation to save data to the primary file group, right? This has a negative impact on the overall performance because we will end up with a lot of IOs. That is the reason why SQL Server decided to have something called asynchronous writeback. And this is something which the interval, the frequency of the asynchronous writeback is something which we can set with a property data flush interval in seconds. So let me go back. And I don't know what it is. Start comment. I don't know what it is. Okay, no worries. So let me go back. How can I get rid of it? Here, okay, cool. When we go back to the configuration of the query store, we can see the, one second here, data flush interval in minutes. So the default is 15 minutes. And this is something you have to consider. This can be the time of the maximum data loss, because it can happen that for whatever reason, SQL Server crashes. So, and all the information which you have currently in memory, which are not already written to disk, which are the runtime statistics, this information can be deleted or not available when SQL Server restarts because of the crash. But honestly, I don't care. So who cares about 15 minutes of runtime statistics? I do not care. So, and this is something you have to take into consideration. Do not lower the value to, I don't know, 1 minute, because you will end up with a lot of IOs, because it is much more expensive to send on a very frequent base small packages of pages to our primary file group instead of sending one big chunk every 15 minutes. So that is the first performance consideration in order to avoid that your query store will harm the overall performance, right? So let's go down. So this is how to enable query store on a database. So use your database, and you can say alter database current or alter database adventure works. It doesn't really matter. Set query store on. So, and when I now execute one of the DMVs which are available whenever you enable query store, for example, this query store runtime statistics, and it is not that hard to guess what it is about, you will see all the runtime statistics about the query which we are running since query store was enabled. So let me give it a try. So when we look into the execution plan, we can see something interesting. We have two plans, we have two runtime statistic query stores available. That one is a clustered index scan with number of rows 1044. These information are coming from the primary file group because we have a clustered index scan. This one is getting from memory. This is a portion which is not flushed yet. So we have 38. Do we have 38? Yeah, we have 38 rows which are currently just captured in memory, which are not already flushed because of the data flush interval of 15 minutes. That is a portion which I can, very unlikely, but when SQL Server crashes, which I can lose. Again, who cares? I don't care. But this is for your understanding, to understand that, or you should understand that this is always a drawback, right? This is always a balance. The balance is a better word here. The balance between performance and information. Okay. Let's go down. So from a configuration perspective, first of all, you can use this databases. So I think you're familiar with the DMV here. This is not a secret. And we can see that there is one additional column since 2016, version to 2016, which tells you for which database you enabled the query store. You can see for AdventureWorks 2017 and White World importers, by chance, I guess, I enabled the query store. So the good thing is that you can use this database query store options in order to get all the configuration settings which you see from a GUI perspective here. From a GUI perspective as well. I don't like to use GUIs. I'm not a fan of it because some of the information are hidden, some of the information you cannot change. It is always better to use the DMVs which are available. And you can see a lot of information. First of all, the actual state and the desired state. We will talk about this in a minute. Then we have a current storage size in megabyte. You have the maximum storage size. This is a flush interval in seconds now. And from a GUI perspective, it is called flush interval in minutes, but 900 seconds are 15 minutes. That's perfectly fine. And by the way, I already did some math for you, right? This is not getting directly from the DMV. Then we have something which is called stale query threshold in days. That means queries or runtime statistics which are older than 30 days will be deleted on a rolling base to ensure that you can keep the size of 2 gigabyte here, 2 gigabyte megabyte, 2 gigabyte, right? This is something you have to set very carefully, because consider the following: you have a rollover every 30 months. But for some reasons, maybe you will run a very expensive query in the year end or whatever. And after, maybe in February, after January is always vacation, you have a lot of trouble, and you have to finish a lot of things. And in February, your colleague asks you, hey, there was one query in the end of December, which we run only once a year. So let's tune this query because it took forever. No chance, because you do not have the information available, because these information will be automatically overwritten after 30 days. Yeah? So maximum plans per queries or per query, that means when one query have more than one plan, that is a maximum number of plans to keep. 200, this is already a very high number, I would say. Query capture mode, as we will see, we will see this later on because this is important. And then we have a lot of other informations which are available since 2019, especially this one. So here, and I will show this one from the GUI perspective. This one here is new. This is new since 2019 to give you more possibility to, how can I put it, to tell the query store which kind of or how often a query must be executed before I even send information to the query store. So think about ad hoc queries, which you only will run once, because this is the nature of ad hoc queries, right? These are, I would say, unsafe queries, so that means you are not running a sort procedure. Instead, you write select all from table, inner join, blah, blah, blah. This is an unsafe query. It's considered as a prepared ad hoc plan. So this is something which you will see in the procedure cache. Is it worth to have runtime statistics for ad hoc queries? It depends, but you have a chance to tell query store not to capture information about these, I would say, the queries which are only running very infrequently. That is the reason here. Okay, so let's go down. Yeah, the capture mode. And this is something, again, I already mentioned, it is worth to understand the idea. So the default is, let me go back. This is one talking about auto. No, there's another one. The query store capture mode, all. The funny thing is, the first time I read the documentation about the query store, Microsoft explains that the capture mode, all, auto, and I guess there's another one, which is none, I guess, but at least all and auto, there is a difference. Auto means SQL Server only will save information about important and expensive queries. And I was thinking, wow, great, this is a smart algorithm. In the end, it is easy as it is. That means SQL Server in 2017 and 16 and 17 will only gather information about a query when you set the capture mode to auto, when the query is executed the third time. It doesn't matter how expensive the query is. So yeah, I would say, again, reading the documentation, it sounds much smarter than it is. It is just about counting how often the query was executed. And once a query is executed 3 times, all the information about runtime statistics and the plan information will be sent to the query store. It is really that easy. Since 2019, there's a change. And that is the reason why we can configure it now manually if we want, but the default is here, something which we configure. But the default is when I change it to auto, it means in 2019, the query have to be executed 30 times, 10 times more than before. Don't ask me why. This was a decision by Microsoft. That means you will only get information about the query runtime statistics once the same query is executed 30 times. And again, think about queries which you are running only once a month or even once a year. You do not get even any information about the query in the query store because it is not executed more than 30 times. That is a problem. So that is the reason why you really have to know about the setting, and you really have to understand the impact of changing the setting here, right? So that's it. I do not want to go through it. You can believe me. This is just an exercise to prove what I'm telling. We go down, down, down. Memory clerk. Memory clerk is interesting because, again, a lot of customers are complaining about the impact of query restore, not so much from an IO perspective and not that much from a CPU perspective, because I guess CPUs are not, in an OLTP system, I wouldn't say CPU is not a bottleneck anymore. That is not true every time, but I would say there are other resources which really makes, or the other way around. I think memory is much more important than CPU. When you have the right index strategy, I think memory is definitely something which you have to worry. CPU for sure also worries because with the CPU you have a so-called bounded maximum worker thread. Yeah, that means the maximum number of threads which can be executed in parallel. That means the more connections, the more queries you execute in parallel, the more CPUs you have to be available. Otherwise, you run in so-called thread pool starvation. Yeah. But let's say you find the right balance between cost and CPU, then you are fine. I do not think CPU is really a problem once you have the right number in place. That is different to memory, because memory is hard to foresee. Because think about a query which is running, I don't know, forever, because you scan all the pages, because you missed to create the right index. Memory is something you should worry, right? So, and this is something CPU for sure as well, but I think memory is definitely something you have to monitor over time. And memory clerk, let me go to the DMV here. There's one DMV. Oh, sorry. There's one DMV, and when you execute the DMV, you can see we have 378 different memory clerks. And the reason why I only have 378, and you will have more, I'm pretty sure, is you have a memory clerk per NUMA node. I have only my PC, my laptop in front of me, which only have one physical core and one logical NUMA node with 8 logical cores. But again, so you can see this is a memory node, which is nothing else than the NUMA node. That means 378 is not the number you will see in your system, because I'm pretty sure you have at least 2 CPUs for your SQL Server. I hope so. There are 3 memory clerks which are related to query restore. 1 second. Here we go. And we have memory clerk query disk store hash map. We have just the query restore, and we have the query restore stats. So the query restore stats, very easy. These are the runtime statistics. So everything which is kept in memory about the runtime statistics is allocated in the memory clerk query disk store stats. And we have query store disk. General clerk for overall query store for an instance should be fairly fixed and in size and small. That's true. I have never ever seen any problems here. The problem is here. And we have a hash map. So this is the, how can I put it? This is a hash table in order to find the right plan for the current query execution. It works with a so-called hash map table, right? Just to find the right address of the query store, of the plan within the query store. Yeah, that's it. So let me do the following. So the numbers are different now, but what I can do is I can easily execute the same query again in another window that I do not need to copy the values. Let me do it. So we can see this is the current memory allocation. When I now make sure that all the queries are captured, and I will run an unsafe a parameterized query to generate a plan per execution. That is nothing else than a so-called plan pollution. You can see I'm concatenating a statement. And there are at least two ways to execute the query. One with a so-called read lookup, because we have non-clustered index on top of the test table, on column 2 to be precise, or it can be a table scan. That is a reason why it is considered to be unsafe. I have two different plans, and depending on the so-called tipping point, you will either see a table scan or you will see a read lookup. So that means I will end up with prepared ad hoc statements in the query execution cache, also the procedure cache, and that is so-called plan pollution. That is something you should avoid. But here I will force this one, just to make sure that it will be executed as fast as possible. Let me go to the results and say discard result after execution. That is much faster. Okay, I will execute this one 400 times. You can see it in loop. And oh, that's great. I think I forgot to create the table. 1 second. Sorry. I need to figure, that is a problem when I do not execute every example here. So I need to find the table first of all. 1 second. The table is called test. I'm pretty sure it will be somewhere in the beginning. No, it isn't here. Let me go here and find table test. Yeah, here it is. You can see it's just a small table, and it's not in master. It is, sorry, I need to make sure this in AdventureWorks 2017. So let me query the table so that you can see how it works or what the idea is. We will end up with 10 rows, 2 columns, and we have a unique non-clustered index on top of column 2. And that is exactly the reason why SQL Server either can use a so-called table scan or a read lookup to satisfy a query like this. Select all from test where column is equal to whatever, right? So again, I will execute the same query. And don't ask me why it is 0, 0. This time it runs. So it's executed 400 times now. And when I switch back to my memory clerk, you can see that just for 400 executions, you can see the impact. It is already doubled. The statistics are doubled. And also the hash map is doubled. And now you're saying, who cares about a few gigabytes? I have an example here where I execute, let me do this. I can do this easily because it's pretty fast. Let me execute this one again and simulate something like 4,000. And what I will do, set no count on, just to avoid the messages. It takes maybe, I don't know, 20 seconds. And arithmetic overflow about, yeah, that's true. 1 second. Enlarge, here we go. My fault. Yeah, it should not be 30. It can be something like 5. 5 should work. And just generating a few more execution plans and a few more runtime statistics, right? That is the idea of the statement here. And I can even stop after a while. Okay, 10 seconds, perfectly fine for 4,000 executions. Let me execute this query again. This was our original, this was our baseline. And let me execute this again. So you can see this is increasing over time. We are now, we are already allocate almost 7 megabytes of plan information. And we have a lot more information and a lot of memory allocated for the statistics, right? You can compare this easily. Statistics and the hash map, going back and compared with the current situation, you can see it is increasing over time. The problem is the following. It is increasing over time. And once you restart your SQL Server, all the information which are saved in the primary file group are now sent back to the memory, because this is the standard behavior of the query store. All the information which you will have on the primary file group, which are created by the query store, will be sent to the memory again once your SQL Server restarts. That is the reason why we have two trace flags here available. Let me see whether I have it. Trace flag. Yeah. No, that is the wrong one. I do not know them by heart anymore, but there are two trace flags, and one of the trace flag is already implemented because it will tell SQL Server to load the query store information to memory asynchronously. Because the problem is the following: think about your RPO and RTO, your recovery recovery time objective. That means normally your expectation is that your RTO is as small as possible. Think about failing over to another node. That should be fast as possible. I do not want to wait for query store information when I restart my SQL Server or when I fail over to another node, right? And that is the reason why with SQL Server 2019, Microsoft introduced and already enabled a trace flag, which I do not have in mind anymore, but you can Google for it, which makes sure that the information are sent asynchronously, because you do not want to wait for the query store just when you restart your SQL Server. And you understand the impact. The impact is not going away. This is always increasing and increasing and increasing over time. That is the reason why you have to limit the query store, not just from a disk perspective, also think about the memory allocation, right? Okay, let me go back because I'm pretty sure I'm a little bit lost in my own script. I think I had, yeah, here we go. Okay, that is about the memory clerk. Okay, let me do the following. I will create another time the same table test, but this time I only insert two records. You can see I have a record 0, 0 for column 1 for column 2, and I have another record which is 1 for column 2 and another 1 for column 2 and 1. Okay, this is easier to query the table, so this is as easy as possible. So I will reset all the information in AdventureWorks 2017 in the query store, because again, the query store is a database scope configuration. So I can reset the query store in AdventureWorks 2017, but can keep my data in my worldwide importer database. So that is definitely something I like. So the problem is the following. When I now execute a query, just to have a baseline, and we will see the baseline in the query store in a minute, and that's perfectly fine. It takes only a few milliseconds. Yeah? So let me enable time and IO and execute again. So it took roughly, what is it? Yeah, it's not even, you cannot even measure the time. Yeah, so it's less than 0 milliseconds. Yeah? Great. So this is our baseline. Now let's set a lock on the table. I have an explicit transaction here, begin transaction, and I update the record in my table test, which I created here, right? And leave the transaction open. Perfect. Great. It works. Yeah? Instantly, it works perfectly fine. When I now execute the same statement as before, select all from test where column 2 is equal to 1. In another session, I wait. I wait forever because I'm currently acquiring a so-called shared log, but the shared log is not compatible with the exclusive log, which comes from my update. So that means I have a clash. And SQL Server never ever resolve blocks for you. It is something about your transactional isolation level. The standard transactional isolation level of SQL Server is read committed. That means I can only read data which are committed. But because I'm updating in another session and I have not committed my transaction yet, I have to wait. That is the usual behavior. So, and I can stop now, or I can do the following. Let me just close this window. I can see the logs. So we can see that there's one session which is waiting for another session. we can see, where do we have it? Here. Exclusive log is grant, that is my update statement, and an intent shared log is currently waiting. So that is the current blocking situation. I have two logs which are not compatible. That means I have a block. Okay, cool. Now I will roll back the transaction, and immediately the other transaction, the other statement is executed. Okay, let me do the following. I can now use, one second, this was to do, no, I will go to the report instead. Let me go to the top resource consuming query. So what we will see here is and this is by the way one report, which is the top resource consuming report, which comes with query store. It's one of the 7 reports which are available. The problem is the following. This will tell you that this query select all from test where column 2 is equal to whatever. Yeah, this is the query execution with the longest duration ever. Okay, now you start your performance tuning. So, and the information you get from the query store is this is the query you should concentrate on because everyone is waiting for the query to be executed. It takes 6 minutes, 6 seconds or 7 seconds. Yeah, 7.5 seconds. Yeah, I should worry about it. But is this really the truth? No. The truth is the query is extremely fast when I do not have to deal with an incompatible log and I have to wait for the log because I am currently running in a blocking situation. That means from that perspective, you have to be very, very careful when you open the query store and just start your performance tuning measurement without thinking about the root cause of your problem. Because how can I make a query faster than a table scan and a select which only takes, I don't know, a millisecond? There is no way to make this query faster. Full stop. The problem is that you have to investigate on wait time. You can see that this query, and this is definitely what I like, yeah, you can change the metrics here. And now I'm on wait time. And this will tell you this query was almost waiting the entire time for an incompatible log. Because you can see the total wait time is almost the same as the total execution time of the query. So that is root cause. The problem here is that we only see, I think this is here, we only see, here, no, I need to go back one second. This is always a little bit confusing for me because I do not like, I do not like the report. I really tend to use the DMVs instead, but let's go back. This is the duration, perfect. And I can now use the wait time another time. And I think from that perspective, I cannot even see it. No, I cannot see it. I think I have to use the query weight statistics. And here you can see the weight category log. That will tell you that this query was waiting for an incompatible log, right? The problem now is that is all the information you get. Even if you use the DMVs, which are available, the DMV will not give you more information than just telling you it was waiting for a log. The problem is it will not tell you the culprit. It will not tell you the incompatible log. Therefore, the only way to fix the query performance problem here is to, this would be my personal preference, to go to the database. No, it's not a database setting. I guess it's an instance setting, if I remember correctly. And here we have something which is called blocked report. One second. or is this even a database setting? Let me go back to options. There should be something which is named blocked process threshold. It's not here, it's somewhere else. That is a problem when you never ever use the GUI. Let me go back to the instance, and when I do not find it, it is not that important. It is important to know. Here we have it. Block process threshold. Again, it is on the instance level. It is by default, it is 0. That means it is off. So, but when you now understand from a query store perspective that this query was waiting forever on a log, and you do not even know the log it was waiting for. Okay, this is select all from table. The only log it can wait for is a shared log for sure. But you cannot see the root cause. The root cause is the update statement. But the update statement is something which you do not see in the query store. So yeah, but now you know that you suffer from blocking, and query store will definitely help you to find the right direction. So what you can do now is use the blocked process threshold, which will now create a so-called blocked process report for you, which you can easily capture. I do not want to do the exercise, I just want to tell you how it works, which you can easily capture in an extended event session. Let's go down and say extended event session. And what you can do is you can create a new extended event session after you enable block process threshold, 5 seconds, and do not decrease it to, I don't know, 1 second or whatever, because you will end up with deadlocks. It's very likely. But call it, I don't know, logs, put events, and say blocked process report, double click on it. Then you can configure, I don't know, maybe you're just interested in database, whatever. And in the end, the extended event will create a blocked process report for you, which is nothing else than an XML document, which will tell you which query was waiting for which query. So one query was waiting for another query and the incompatible logs. And that is something which will give you the root cause. The root cause is the blocking situation. And how to resolve the blocking situation? It's very easy. Either you can go with read committed snapshot isolation or allow a snapshot, or use in-memory OLTP. Maybe sometimes you have to set the right indexes to avoid that the entire table is blocked. There are different ways to resolve blocking problems. But again, coming back to the query store, to the report, this one, this is important. It is really important to understand the root cause of the long execution time. From that perspective, that would be your number one query you have to tune. Nothing to tune. Okay. That is something you always have to keep in mind. So let's go further. Let's go down, down, down. Okay. Take query regression. Okay, let's do the following. Now we understand that there are reports available. We understand that the query store consists of two query store, runtime statistics, plan statistics, and all of the other things I already mentioned. So now I guess it is time to figure out how to detect a query regression. So let's do the following. I just want to ensure that the example is working. So therefore I enable query store again. Make sure that every query is captured. That the compatibility mode to SQL Server 2019, perfect, disable automatic tuning. Oh, sorry. This is just, I would say, to make sure that the example is working. That's it. Ensure it is auto update statistics set to 1, perfect. And now I will create another time the table test. It is again a very easy one, only 2 columns. This time I insert a little bit more records, 100,000 records, which is a very fast operation. and I will create an index on column 2, a non-clustered index. So that's not fully covering, it only covers column 2, but not column 1. So, and because of the way I was inserting records, you can see it here, I have an uneven distribution. This is something which we can figure out even with statistics, or I can easily ask SQL Server to give me a count distinct in order to see how many times a specific value is available in either column 2 or column 1. So you can see we have a very, very, very uneven distribution. We have we have 10 times the value 1 here, and another time we have 999 and of course times the value 0. A complete uneven distribution. Okay, that was the reason that I inserted the record like this. So the test table looks like this. You can see we have a lot of time 0, and sometimes, maybe in the end, we will see some the number 1. Okay, that's an uneven distribution. Okay, perfect. So let's go further and just make sure that the query, that the plan cache is flushed. I create a stored procedure, call it a regression. And again, I'm using a very simple statement. Select all from test where column 2 is equal to the parameter. And now the problem begins. Let me set statistics IO on. I will execute the first time the stored procedure with the selective parameter value, which is 1. You remember 1 is there only 10 times. Okay, a very selective one. That means SQL Server have 2 ways to execute the query now. And sorry, I need to enable the execution plan. So either a table scan or a so-called read lookup. So table scan means SQL Server has to scan the entire table, which means it has to read all pages which belongs to the table. But here there's a much better way to get the information. We can use, or SQL Server can use the index seek to get 10 times or 10 matches, because we have a covering index on column 2, but only on column 2, not on column 1. But now SQL Server use the index seek to get the best out of the index, which is just a forward scan, a very, very efficient and fast operation. And for every row of the 10 rows, it will use a nested loop to get the additional information for column 1, which is not covered by the index, but we ask for. See it here. It will get the information, the value for the appropriate value for column 1 in a so-called read lookup, because we have a heap. We do not have a cluster table, otherwise we will see a read lookup, instead we will see a key lookup. But the overall pattern is something which is called bookmark lookup. That is a bookmark lookup. Good, that looks fine. We will end up with 12 logical reads only. Okay, perfect. That's a very efficient plan. Let us do the following. I will execute the query now another time with the, one second. No, first of all, I want to show you the statistics. And we can see from a statistic perspective, we have a range high key. And that means when I ask for the value 1, I will end up with 10 rows. When I ask for 0, I will end up with all the other rows in the table. You can see the rows which I have in my table, the rows which are sampled, and so forth. The most important one is this one. This is the information SQL Server gets. This is the so-called cardinality estimation based on the histogram to tell SQL Server either to choose the read lookup, the bookmark lookup, or the table scan. Again, in this case, the read lookup is much more sufficient. So when I now execute the query 20 times, just a matter of a few seconds, it perfectly scales, wonderful. So, and I think you're familiar with the algorithm SQL Server implemented since years. There's a trace flag which is now enabled by default, which is not a proportional statistic update anymore. It's something which is, which I think is SAP asked for. That means the more rows we change in a table, or the other way around, the bigger the table is, the longer it takes that a statistic update will happen, and therefore also procedure recompile will happen. So, but overall, I would say it is definitely true to tell or to have this rule in mind, which means when I insert 500 rows plus 20% of the existing data or change it, it's not just inserting, it means also deleting, and also means updating. When I have a change like this for a table, we will end up with a statistic recompile. So let's do it. That means I need to insert 20,501 record. Okay, let's do it. Great. And now we can see that we still have a very uneven distribution. Instead of 10, we have 13 times the value 1, but this is still a very uneven distribution. So when I now execute the query with the non-selected parameter, which is 0 as we know, because of the statistic change, SQL Server automatically recompiles the plan for the stored procedure, right? That means we will end up with a different plan. The plan looks like this. I forgot to, okay, that was not a good one. I forgot to enable the execution plan. We can see that this time SQL Server prefers to use a table scan, because the assumption is based on the histogram again, and we can see the actual number of rows and the estimated number of rows. Estimated number of rows is the number of rows which determine the plan. Is I cannot move the mouse because otherwise the pop-up window will disappear. But you can see the estimated number of rows is something about 120,000. So, and in this case, it doesn't make sense to use a read lookup with a loop, which means for every row, I have to search another time in my table. This is horribly insufficient. That is the reason why we will end up with a table scan instead of a read lookup. We can see that this time, SQL Server have to read the entire amount or the entire number of pages which belongs to this table. But this is an efficient plan, as far as I do not have a covering index. So we can see that the statistic was updated just 2 minutes ago. This is an update here. You can see the histogram changes. So, and this is again, this is the so-called cardinality estimation. So let me execute the query now with the non-selected parameter another time, but 20 times as before. Honestly, don't ask me why I have it 20 times. I don't know the reason anymore, to be honest. But okay, I think I can already close this one. The most important one is the following. Let me open the query store report, which is a regression. So the funny thing is, I cannot see anything. That is a bug, right? So I need to configure it. Sometimes it works, sometimes it doesn't work. Okay, I cannot use the regression anymore. Or not anymore, I cannot use it. It is not very reliable. But what I can do instead is I can use the top resource consuming query. And we can see this one was the one which I executed. All right, select all from table test where column 2 is equal to either the selected parameter or the non-selective parameter. That was the one which was selected for the selective parameter. It means I have, and this is just tells me that I canceled the query. Yeah? Just concentrate on this plan and on this plan. We can see for the same query, we have two plans, the table scan, and we have the nested loop one, yeah? The read lookup. So now people do the following. We have the matrix duration, and I was asked to tune the query. So what can I do? I can easily see that I have a regression. I have two plans and one plan is much better than the other plan. Okay, how can I avoid that this plan is used because it seems it takes much longer? Okay, I can highlight this plan and can fix it. Forced query 89, that is the current query, to, one second, to try to use plan 93. That is plan 93, and we have another plan which is 97. Okay, let's do it. We want to, yeah, why not? It's a good idea. It seems it is a very nice idea. So now we can see a hook. The hook is nothing else than it will signal you that this plan is used forever. And now you are in big trouble. Let's go back to my script. Just need to close a few windows here. Yeah. Second. Maybe this works. I cannot guarantee that this works. Sometimes it works. It doesn't work this time. Don't ask me why. This was about automatic. What was it? Plan regression. Yeah, fixed automatic plan regression. But this is nothing I want to show here. See, the problem is the following. When I now execute the same query another time with a selected parameter, with the execution plan, we can see we have the plan as before. It is perfect. I have 15 reads, a little bit more than 12 in the beginning because I inserted, I think, 20,000 rows additionally to the table. Perfect. And now I use the same plan, which is forced now, but I run the same query with a non-selective parameter. Let me execute this one. This one takes much longer than before. And you can see this is a plan which I forced. There is no alternative for SQL Server. It will always use this plan for whatever parameter. It will always use the same plan because we forced the plan for this query. Now let's have a look. What does it mean? It means we will end up with, I think there's a comma in US, yes. We will end up with 120,000 page reads. One page is 8 kilobyte. That means when I multiply this with 8 kilobyte, you can already imagine how many pages SQL Server have to read from your file into your buffer, which is a physical I/O, get the pages from the buffer, which is a logical I/O, but the pages will remain in the buffer as far as your buffer is big enough. That means I completely waste memory for pages which shouldn't be there because the plan is completely insufficient. So, and the funny thing is, let's have a look. So the current the estimated subtree cost is something about 0.042. This is completely wrong. The estimated subtree costs or the overall estimation is based on cardinality estimations. That means the first plan, the read lookup, which I created by the first execution with a selective parameter, which is now forced, that is a plan which is used over and over again. And you can see there is nothing mentioned about actual subtree cost. It is always about estimated subtree cost. The estimated subtree costs are part of the procedure cache. That means the estimated subtree cost will never ever be precise. These are not the real costs. That is a problem here. I will show you the following. So when I now go back to my report here, I will close this one. I think that was one, and I refresh the report. We can see what happens. This plan is it's not about the duration. Let's go to the logical reads. You can see this was a first plan. This one, table scan, for the non-selective parameter, which was okay. That was one for the selective parameter, which I now forced. And this is my current execution. And now you are in trouble because you forced the plan. It was you, it was not SQL Server. SQL Server will use your plan over and over and over again. And now you come back to the query store and you wonder, what the heck is going on here? Because I forced this plan, but this plan is not a good one. The problem is the following: when I go to my when I go back to my script and I have a better understanding about the root cause. The root cause is, let me go here. Yeah. The root cause is that the plan is used over and over again. Now I am simulate another statistics recompile, which I can also use with execute stored procedure with recompile. It's nothing else than compiling a new plan. So guess what? It's still the same plan. Even with a recompilation, the plan is fixed. Now I think, what can I do? Why is my query that slow? Okay, I understand. I have a non-covering index. Make this index covering. That means I create a new index on column 2, which is perfectly fine. Yeah. Also include column 1. That means there is no need to use a read lookup anymore because all the information can be retrieved from the index. Let me execute this query. It will create an index perfectly fine. Execute the plan again, or the query again, and guess what? SQL Server still use the forced plan. It will not even consider the supportive index. This is a perfect index. But again, the plan will not go away. The only chance to get rid of it is to highlight this one. And this is really hard. For sure, there are DMVs available, but you have to remember that you force the plan because otherwise you are in trouble. You do not even understand why the new plan is not used. So let me unforce this one. Unforce here. Okay, when I now execute the query again, we will see that we will end up with a clustered index scan instead. Or not a clustered, a non-clustered index scan, index seek, right? Index seek, sorry, non-clustered index seek. We get rid of the bookmark lookup. We will end up with 330 rows only, pages only. And when I now execute the same query with a selective one, we will have the same plan in index seek with only 2 logical reads. That is how to deal with plan regression. The problem is that it is so easy to force a specific plan and make your performance even worse because you cannot foresee how the forced plan performs with different selectivity. That is a problem here. Okay, I will show you one last example in the last 10 minutes. That is about the Cardinality Estimator. And believe me, this is a major performance issue. And Microsoft is currently working on a solution. Because a lot of customers are complaining that upgrading to SQL Server 2019 means some of the queries are running much, much, much slower. Most of the queries are running faster. But normally you concentrate on queries which are running slower than before because you expect that a new SQL Server version is faster than the older one. Okay, you will only concentrate on slow performance. You will never ever complain about good performance because this is something you expect from Microsoft. Let me do the following. I will simulate a migration from 2008. And believe me, it's the same for 2012. This was just because a customer used 2008. That was the reason why I took this example. But this is true for every upgrade from 2012 to 2016, from 14 to 19. There's always a change in the cardinality estimator. And in order to understand the cardinality estimator, I will just use this algorithm, which is some kind of documented. Let me close a few sessions here. Okay. Let me do the following. I will execute this one. So assuming that you have a table like this, we have 2 millions and we have an even distribution, and I will create the table in a minute. Yeah, just first of all, you do not even have to understand the algorithm, but you have to see, and I'm pretty sure you see that there's a difference. That is the legacy cardinality estimator. That is the older version. That is a new version, 2017, I guess. I'm not quite sure, but it is one of the newer algorithms, so one of the newer cardinality estimator. Okay, you have a conjunction and you have a disconjunction. A conjunction is a predicate which is combined with an and. A disconjunction is a predicate where you combine two, I would say, two logical conditions with an or. That's a disconjunction, that is a conjunction. You can see that there's a difference. We will end up with, what is it, 500,000 for the legacy cardinality estimator for a conjunction, but we will have 700,000 for the new one. You can see there's also a difference. 1.5 million as a disconjunction and 1.3 million as for the new cardinality estimator when it comes to the evaluation and the estimation for disconjunction. Okay, I will keep this open. What I will do now is the following. I will create a table, insert 2 million records, and have 2 unique values in column 1 and 2 unique values in column 2, which is exactly this example, right? Let me execute this one. And it's pretty fast, believe me. I need the execution plan here. It takes maybe 10, maybe 20 minutes, 20 seconds, minutes, sorry. It depends. It's already very late here, 1:30 a.m. But no worries, it's done. So my PC is still, still supporting me. I will create 2 statistics with full scan just to make sure that I have a the most precise statistic available because I'm not creating an index. So, and what I will do now is the following. I will set the cost threshold for probabilism to 5. First of all, just to reset everything, flush the procedure cache, set the cardinality estimator to SQL Server 2012 by setting the compatibility level of the database to 2012. That means whenever you change the compatibility level of a database, it will automatically change the database for you, as is the cardinality estimator for you. That means we will start up with the SQL Server 2012, which we now want to migrate, I think, to 2017. So a very, very common example, all right? And by the way, I mix it up. I was telling you in the beginning that this is 2008 to 2016. This is not true. This is 2012, which is even more realistic, yeah, to, I think, 2019 or 17. So very, very common upgrade. Yeah. So the compatibility level is set to, no, it is not, to execute this again. Yeah, now it is set to SQL Server 2012. Okay. When I now execute the following query, we will see 16. Okay, sometimes it is 19, sometimes it is 16. This is something I have to know because this will do the magic. So I will configure the cost threshold for probabilism to 16. It can be 50, it can be 100. There's always, as you will see, a difference in terms of the query execution plan, which is created because it depends on your cost threshold for parallelism and the cardinality estimator. And because the example which I created works perfectly when I set my threshold for cost threshold for parallelism either to 19 or to 16, today I have to set it to 16. Don't ask me why. Sometimes it's 19, sometimes it is 16. I set it to 16. So I will reset the query store, make sure that all queries are going to the query store. And now I execute this query the first time. in SQL Server 2012, right? And you can see I use a disconjunction. So let us execute this query. We will end up with parallelism because you remember when I execute this query where I do not allow SQL Server to run more than one thread to fulfill the query. So to be precise, this is a so-called task. So we end up with 16.9 or whatever. So the estimated subtree costs. I set the cost threshold for parallelism to 16, which means the estimated subtree cost is greater than 16. SQL Server now considers parallelism because, again, this threshold is reached. That means we will end up with a parallel plan, and the estimated subtree cost is down to 6.6. Okay, perfect. What is important? You can see the estimated number of rows for all executions or per execution or rows per read, per execution is 1.5 million. Okay, let's go back to our calculation. This is the old legacy cardinality estimator for a disconjunction, which is nothing else than an OR. 1.5 million rows. This is a guess. It is a cardinality estimator. That means it is an estimation based on consumptions, based on a rule, based on an algorithm. And because SQL Server estimated to get 1.5 million, the execution plan looks like this. Okay, parallelism, table scan, hash match, another parallelism, sort. Great. Now, let me execute the same query in SQL Server 2019 or 2017, it really doesn't matter. I just want to make sure that the database level is set to 140. Perfect. I flush the procedure cache, which is not even needed because with every database change, your procedure cache is automatically flushed just to make sure that everything is working. And now I execute the same query as before in SQL Server 2017. So let's do it. We will end up with a complete different plan. This plan is a select, a hash match aggregate, and a table scan. For the same query, we have two plans. And the estimated subtree cost now is 15.4. When we, and this is interesting, look or try to understand, well, you can see it already, the estimated number of rows per execution is estimated as 1.3 millions. Let's go back to our calculation. It is 1.3 millions. This is exactly the algorithm which is used to estimate the number of rows. So what do you think? Which plan is better? Which plan is better? That's an interesting one. So from a cost perspective, this plan costs 15. The other plan was down to 6.6, if I remember correctly. The other plan was a parallel plan. This one is just single threaded. Okay. This one has a memory grant of, I would say roughly 1 megabyte. The other one had a little bit more, 1.2 megabyte. Okay, the logical reads are the same because we have a table scan in place. So nothing I can compare here. It has to be the same. The problem is, I will tell you that this plan is worse than the other plan. Why? Think about the cardinality estimation. This is a plan which perfectly scales and works when you retrieve 1.3 million rows. But actually, you can see the estimated number of rows, and you can see the estimated number of rows to be read, and you can see the actual number of rows in the first third of the pop-up window is 2 million. This is something which we already know. 1.3 million is not as close to 2 million than 1.5 million. You remember the other plan? The other plan was based on the assumption that we have 1.5 million rows, which is closer to 2 millions. It's not, I would say, it's still worse, or it's still bad. It's still a bad guess, but it is better than 1.3 million. That means you will end up with plans when you execute a query like this. By just changing the cardinality estimator, you will get two different plans. And now it is on you to decide what is the best plan. And you can see this in your top resource consuming query report again. We can see two plans, right? This one is the first one, and this one. And now it is on you to decide which query performs better. How can we do this? Let me select this one. Let me select this one. And you can compare them here. You can compare both plans. You can see the reason why we will end up with this plan and why we will end up with this plan is the estimated number of rows versus actual number of rows, but the actual number of rows are not visible anymore. Instead, estimated number of rows to reread. But the main reason is that we have a cardinality estimator, which is 140 for version 17. And for 2012, we have the cardinality estimator 70. That means only the change of the cardinality estimator will cause SQL Server to create either plan A or plan B. So how can I fix this? Because sometimes this query is better, sometimes this query is better. It really depends on the estimation versus actual. In this case, the newer cardinality estimation is better than the old one, but this is never ever always the truth. The problem is, how can I fix this plan? There are two ways to do it. When I know that the old plan is a preferred one, I can use option use hint force legacy cardinality estimation, which means SQL Server will execute the query as it is in SQL Server 2012 with the old cardinality estimation. Because the problem is, I can try to create a statistics on both columns to give SQL Server a better guess about or better idea about the estimated number of rows. But this will not work. When I create a statistics on two columns, which is a so-called composite statistic, SQL Server will never ever create a composite statistic by default, by its own. When I now execute the query again, guess what? The problem is we will end up with the same plan as before, zoom to fit, because the actual, the estimated number of rows is still 1.3 million. Why? Because this is a disconjunction. For a disconjunction, I cannot rely on statistics. Only for conjunction. That means you can fix plan regression by cardinality estimator only by creating statistics or even a supportive index when you have a conjunction, not for queries with a disconjunction. Because even if you run a query with a disconjunction, I can show you, create a supportive index, right? Column 1 and column 2, perfectly fine. Let's do it. I create this one. It takes maybe, I don't know, a few seconds. So when I now execute the same query again, we will end up with a different plan. But instead of a table scan, we have an index scan, and you can see what happens. So there is the index, it is an index scan, it is not an index seek. So there is no reason to create an index for a disconjunction. It cannot work because you will always end up with a so-called residual predicate for the second column, which we can hopefully see here. No, we cannot see it here. No, because this is just a full index scan. That means it will completely read all the rows from the index. So this is definitely very, very hard to fix. For a conjunction, easy, either create a statistic or an index. For this conjunction, the only way is to use option hint legacy. What is the right name for the hint? One second. It's called force legacy cardinality estimation. That means whenever you upgrade from one version to the other, and this is Microsoft's recommendation, by the way, migrate your database to the new version, but leave the compatibility level of the database in the old compatibility level, run it for a while, but keep query store on. So, and after a while, it is on you to compare the queries in the query store to figure out whether you have a plan regression. If this is the case, again, you have 2 or 3 options. Create a statistic for conjunction, create an index for conjunction, or hint the query when you have a disconjunction. That is a way to avoid plan regression by cardinality estimator changes. And believe me, this is really, really a big impact. So I guess that's it from my end. We are already running a little bit out of time here. Yeah, 1.5 hours. Any questions? No question?
Feel free to unmute yourself and ask a question if you have something.
Okay, that's also fine.
I did have one question for you.
Sure, sure.
When you talked about the forced query plans,
Yeah.
Is there a query to look, say you go into an environment that is not yours, or
Yeah.
you're new to an environment, where you can look and see if there are forced query plans in use?
Yeah, you can see it from, there's even a report, query with forced plans.
Huh.
I think I do not have it anymore, but I can still do it. Let's force another one, force query. Let's go back to the report and refresh. And now we can see this is a forced one.
Ah, very good. That way you can
Yeah.
find ones that are out there, not necessarily it's
Exactly.
something chasing.
Exactly.
Yeah. Okay.
And there's another report which is tracked query. So now let's assume that you force the plan for a specific query, and you want to see whether it was a good or bad idea. So that means you can track queries over time. So for example, that is a query 3. So you can see it from here. So plan ID is 3, query ID is 3. So I can use 3 now in my track queries and enter 3. And now you can see the timeline, and you can see I would say the runtime statistics and also the different plans over time. So it means you can track a specific query to see whether you are, let's call it a performance attempts. Yeah, I think it is an attempt, because when you're already sure, there is no need to track a specific query, right? But if you're not sure about whether it was a good or bad idea to set a specific index or hint a query or whatever, you can track a specific query and see how it performs over time.
Excellent. Thank you.
Welcome.
Anybody else?
No one. Okay.
Okay. Well, again, I'll remind y'all that this recording will be posted. Just check back on this meetup page, and we'll have